This podcast was created as a supplemental learning resource for this course. The content is based on assigned course materials, including open educational resources, textbook chapters, instructor-developed explanations, examples, and applications connected to course topics. AI tools were used to help transform course material into a conversational podcast format, including the use of AI-generated narration. The AI narration is intended to make the material more engaging, accessible, and flexible for students. However, the podcast should not replace careful reading of assigned materials, reviewing course lectures, or completing course activities. Any interpretations, examples, or explanations included in the podcast are provided for educational purposes and are the responsibility of the instructor. Students should rely on the assigned readings, course lectures, and official course materials as the primary sources for exams, assignments, and class discussions.
So I want you to picture the glow of your laptop screen at like 2 in the morning.
Oh, I have definitely been there. The classic undergrad experience.
Right. You are just staring at a spreadsheet, and it is filled with hundreds of rows of data.
Just numbers blurring together.
Exactly, because you have spent the last 3 months pouring your absolute life into a psychology study for your research methods class.
Which is exhausting.
It really is. I mean, you designed the experiment, you recruited the participants, which is a nightmare on its own.
Dealing with the headaches of scheduling, sending out reminder emails, all of that.
Yeah, and then you crunched the numbers until your vision literally went blurry. So now you have this incredibly well-organized digital folder sitting on your desktop.
The Holy Grail.
Yes. It holds the actual answers to the question you set out to explore all those weeks ago. But here's the tragedy.
Uh-oh.
Imagine you close the laptop, you graduate, and you never, ever open that folder again. The data just sits there, trapped in silicon, slowly becoming completely obsolete.
That is depressing.
It is. And the big question is, if you do all that work, but you leave the findings in the dark, did you actually do science?
I feel like a lot of students would hear that and say, well, yeah, I did the experiment. I got the grade.
Yeah.
Science achieved, right?
Which makes sense from a student perspective, just trying to pass the class.
Exactly.
Yeah.
But if we look at the core of how scientific advancement actually works, the harsh answer is no. A solitary experiment locked in a desk drawer is honestly just a personal hobby.
A very stressful hobby.
Right. Because the cyclical model of research, which we talked about way back in Chapter 2, tells us that science is fundamentally a social, cumulative enterprise.
Yes, social and cumulative. Those are the key words.
It only really functions if it is a massive ongoing conversation happening across decades and across continents.
And that cycle completely breaks the second someone hoards their data.
Right. Because if you don't broadcast what you found, nobody can learn from your discoveries. And, maybe more importantly, nobody can critique your methodology.
Oh, absolutely. Critique is essential.
And nobody can try to replicate your work to see if it holds up.
Which brings us to the core mission of today's deep dive. We are digging into the actual mechanics of sharing your findings with the world.
The crucial final step.
Exactly. We are unpacking Chapter 11 of your research methods journey, which is all about presenting your research.
So we're moving from the lab to the page.
Yes.
Yeah.
The goal here is to take all that brilliant, exhausting work you've done and translate it into a specific format that the rest of the scientific community can actually ingest and use.
Which means we have to talk about the formatting.
We do. We are talking about formatting a proper American Psychological Association style report, or as you probably know it, APA style.
I have to admit, hearing the phrase APA style usually makes my eyes glaze over instantly.
Oh, I totally get it. It has that reputation.
It just feels like an exercise in, I don't know, arbitrary gatekeeping. Like, why does it matter if my margins are exactly 1 inch?
Or the exact placement of a comma.
Right. Or where I put a period in a citation. It feels like academic snobbery rather than actual rigorous science. I always wonder, if my data is good, shouldn't that just be enough?
I completely understand why it feels that way. And trust me, you are definitely not alone in that frustration. Every undergrad hates it at first. But let's try to look at it through a different lens for a second.
Okay, I'm open to it.
APA style isn't actually meant to be a torture device for undergrads, even if it feels like one. It is a highly evolved, highly specific genre of communication.
Like a specific dialect.
Sort of, yeah. Think about open source software code. If you write a brilliant computer program, but you invent your own completely unique coding language and you don't document any of your variables.
Nobody else can run your software.
Exactly. It will just crash.
Yeah.
Other programmers will look at it and have no idea what you did. APA style is basically the universal coding language for psychology.
Okay, so it's about interoperability,
Mm-hmm.
making sure my research can plug into the broader scientific network.
Precisely. And the textbook breaks this coding language down into 3 distinct levels, which I think really helps demystify the whole thing.
What are the 3 levels?
They are organization, high-level style, and low-level style. So let's start with organization.
The big picture structure.
Right. Empirical research reports follow a rigid, unchanging template. It is always abstract, introduction, method, results, discussion, every single time.
I will concede that the organizational predictability is incredibly helpful as a student reading these papers.
It saves so much time.
So much time.
Mm.
If every researcher chose to write their papers like a mystery novel,
Mm.
burying the hypothesis on page 12 just to build suspense, it would be a total nightmare to try and review the literature.
You would spend hours just trying to figure out what the study was even about.
Exactly. By keeping the structure fixed, it massively reduces the cognitive load on the reader. You don't have to read a 20-page paper from start to finish.
You can just jump around.
Right. If I only care about how they recruited participants, I can navigate straight to the method section. Or I can skip right to the results to check their statistics.
It is pure efficiency. You always know exactly where the blueprints are kept. So that is the organization level. Now, the second level is high-level style.
And this is about the tone of the writing, right?
Yes, this dictates the overarching tone. Scientific writing must be formal, it must be straightforward, and it must be relentlessly objective.
So no flowery language.
None. You aren't writing a persuasive op-ed for a newspaper, and you certainly aren't writing a creative memoir. You are presenting evidence.
It's just the facts.
Just the facts. And maintaining that strict objectivity requires a very specific approach to language, which leads us to one of the most important concepts in the chapter, person-first language.
Oh, I've actually seen this shift happening a lot in recent literature. It's a big deal right now.
It is a critical rule.
Yeah.
We no longer let a diagnosis or a condition or a demographic label define the entirety of a participant.
How does that look in practice?
So, in our writing, we describe people diagnosed with schizophrenia. We absolutely do not label them as schizophrenics.
That makes total sense.
Mhm.
From a purely methodological standpoint, I can really see why this is so important for scientific precision.
Tell me more about that. How does it tie to precision?
Well, when you write a schizophrenic, you are rhetorically reducing a highly complex human organism down to a single variable.
Yes, exactly.
You're basically implying that the medical condition is their entire operational definition. But by using person-first language, by saying a person with schizophrenia, you are acknowledging that they are a human being who just happens to possess this one specific characteristic among thousands of others.
That is a phenomenal way to frame it.
It keeps the researcher objective. It prevents them from oversimplifying the people who are actually generous enough to participate in the research.
It prevents confounding our own interpretation of the people we are studying. It really is about accuracy just as much as it is about respect.
Are there other examples of that?
Yeah, the same logic applies to how we describe their actions in the lab. We write, the students completed the questionnaire. We actively avoid writing, the subjects were administered the questionnaire.
Oh, yeah. Subjects being administered sounds like you were talking about, like, chemical regions in a beaker or something.
It sounds so clinical and detached.
Humans in a psychology study aren't passive objects just having things done to them. They are active contributors who are performing cognitive or behavioral tasks for you.
Exactly. Using the active voice reflects the actual reality of the experimental environment much more accurately.
It's all about being precise with reality.
It certainly is. Now, another major pillar of this high-level objective style is how researchers describe their actual findings. And I see students fall into this specific trap constantly on their very first paper.
What do they do?
They run their data, they get a statistically significant result, and they are thrilled, so they excitedly type, "This study proves that my hypothesis is correct."
Oh, man. I completely get the urge to write that, especially after months of hard work. You want that validation.
You want a victory lap, but the word proves is basically outlawed in empirical research.
It really is. Why is the scientific community so incredibly allergic to claiming proof?
Because claiming absolute proof demonstrates a fundamental misunderstanding of how statistics actually work. Good researchers use words like suggests, indicates, or supports
We call this hedging our conclusions, right?
Yes, hedging. Let's dig into why we have to do that.
Let's tie that back to what we covered in Chapter 13 regarding inferential statistics, because it really comes down to the mechanics of probability, doesn't it?
It does. Think about it. Whenever you run a study, you are only ever testing a tiny sample of people. You test, say, 50 undergrads at your specific university, and then you try to make a broad inference about millions of human beings.
Right, you are generalizing.
Exactly. Because you aren't testing every single person on Earth, you are inherently dealing in probabilities, not certainties. And mathematically speaking, you can always make an error.
Like, for instance, a type-I error, the classic false positive.
Walk us through what that means in this context.
So, you analyze your sample of 50 undergrads, and the math says you found a real significant effect. But in the actual broader population out in the real world, the effect doesn't exist at all.
Right. It's a phantom finding.
You just happen to randomly select 50 people who naturally skewed your data in a weird direction.
Yes, by pure chance. Or, on the flip side, you could make a type 2 error, which is the false negative.
Where you miss something that's actually there.
Exactly. The psychological effect really does exist in the real world, but your specific sample was too noisy, or maybe your measurement tool was too blunt, so your data just missed it entirely.
So because those statistical errors, type I and type 2, are basically omnipresent threats, we can never logically claim 100% certainty.
Never. Science does not traffic in absolute proof, it only traffics in evidence.
It really forces a lot of humility into the writing process. You have to admit you aren't uncovering absolute undeniable truth. You're simply adding one more data point to the collective scale.
Humility is the absolute perfect word for it. You are contributing to the conversation, not ending it.
Okay, so that covers organization and high-level style. What's the third level?
The final level of APA style is the low-level style, and this is the granular stuff.
The dreaded granular stuff.
The nitty-gritty. The grammar, the spelling, the precise formatting of headers, and of course the citation mechanics.
The rules everyone has to constantly look up online.
Exactly. We won't list every single comma rule today because that would take hours, but let's address the one that causes the most friction for students. The et al. Rule.
Ah, yes. Latin for and others. I know we use it to avoid writing out massive paragraph-long strings of names every single time we cite a paper, but the rules around when to actually trigger it always trip me up.
It's a common stumbling block. Let's clarify the mechanism. If you are citing a paper that has 3 to 5 authors, the rule states you must list every single author's last name the very first time you mention that paper in your text.
So I have to write all of them out initially.
Yes. You are basically formally introducing the entire research team to your reader. But for every subsequent citation of that exact same paper later in your document, you simply use the first author's last name followed by et al.
Let me see if I have this. So my first sentence in the introduction is something like, Smith, Johnson, and Lee found that sleep deprivation severely impairs memory.
Perfect.
And then 2 paragraphs later, when I bring their study up again, I just write, furthermore, Smith et al. Demonstrated that this effect worsens over time.
You have it exactly. However, there is an exception. If the paper has 6 or more authors, the team is just too large for a formal roll call in the text.
It would ruin the flow of the sentence.
It really would.
Yeah.
So for 6 or more authors, you use et al. Immediately, starting from the very first citation.
Okay, I understand the rule, but I'm going to push back again here.
Go for it.
Does a journal reviewer really care if I write out all 6 names? Like, how does mastering this kind of tedious minutia actually improve the science?
It's a fair question. Think of citations as the hyperlinking system of the pre-internet era, which we still heavily rely on today.
Hyperlinking.
Yeah. When you cite properly, you are maintaining the integrity of the scientific web. A reader needs to be able to seamlessly cross-reference your in-text citation with your bibliography to find the original source.
So they can go read it themselves.
Exactly. If you start making up your own citation shorthand or messing up the names, that hyperlinking system breaks down. It creates dead ends.
That makes sense functionally.
And plus, on a purely psychological level, mastering these low-level details signals to the scientific community that you are a meticulous person.
Oh, I see. It's about reputation.
Yes. If a reviewer or a reader sees incredibly sloppy formatting, they're going to subconsciously wonder if your data collection in the lab was equally sloppy.
That is a great point. It's about building trust with the reader before they even look at your numbers. If you can't be trusted to format a comma, can you be trusted to run a complex statistical analysis?
Exactly. Trust is everything in research. So, Now that we have the coding language down, let's look at how to actually build the program. Let's move into the first half of the empirical report, the setup.
Which consists of the abstract and the introduction, right?
That's right, the setup. Let's start with the abstract.
The abstract is such a strange beast to me. It appears first on the literal page, but I've always found it by far the hardest section to write.
Oh, without a doubt. And that is because it is an elevator pitch. You are tasked with writing a comprehensive summary of your entire months-long study in about 150 to 250 words.
Which feels impossible.
It is so tight. You must state the research question, outline the participant demographics, summarize the core methodology, report the primary statistical findings, and state the real-world implications, all in a single, short paragraph.
Which is exactly why attempting to write it first is usually a complete disaster.
You just stare at a blank screen.
You can't summarize a narrative you haven't even finished constructing yet. It seems like the only logical workflow for a student is to write the entire paper, get all your thoughts down, and then distill it down into the abstract at the very end.
That is the ultimate pro tip. Honestly, save the abstract for the very last thing you do. Once that is done, the real narrative of your paper begins in the introduction.
How do we structure the introduction so it doesn't just ramble?
To visualize how a strong APA-style introduction is structured, I want you to imagine an hourglass, or maybe a funnel.
A funnel, okay.
You start incredibly wide at the very top, you slowly narrow down through the middle, and you arrive at a very sharp, highly specific point at the very bottom.
How does that funnel shape map onto the actual paragraphs we have to write?
Let's build a hypothetical introduction together to show the mechanics. Let's use a classic example. The very top of the funnel is the opening. The goal here is to introduce the general topic and hook the reader by explaining why this phenomenon actually matters in the real world.
What topic should we use?
Let's say we are writing a paper based on that famous study by Drews, Pispatathy, and Strayer regarding cell phones and driving.
Oh, that's a great one. So at the top of the funnel, the opening, I shouldn't be talking about braking reaction times or driving simulators just yet.
No, way too specific.
I need to establish the broad societal context. So I might write something like, the massive proliferation of mobile technology has fundamentally altered daily life. But integrating devices like cell phones into complex, high-stakes tasks like driving raises significant public safety concerns.
Perfect. It's broad, it's accessible to anyone, and it clearly establishes the stakes. We care about this because it involves public safety.
Right. Where do we go next?
From there, we move down into the middle of the funnel, the literature review. This is where you begin summarizing previous specific studies that other people have done. You are basically laying down a breadcrumb trail of past research to show the reader what the scientific community already knows.
Okay, so I start pulling in prior studies to build my case. I might write, previous laboratory research has robustly demonstrated that engaging in cognitive or verbal tasks can severely impair human performance on simultaneous perceptual and motor tasks.
Excellent. Notice how the focus just narrowed.
Yeah, I went from cell phones in society down to verbal tasks impairing motor skills.
You are guiding the reader's attention exactly where you want it, and that literature review leads directly to the very tip of the funnel, the closing. This is where you state your specific, testable hypothesis.
So I bring it to my actual study. Therefore, the present study was designed to test the hypothesis that engaging in a conversational cell phone task will significantly delay a driver's braking reaction time when compared to a driving control condition without a cell phone.
Boom! You landed perfectly on the specific parameters of your experiment.
Yeah.
Wide to narrow.
Okay, wait, I'm having a bit of deja vu here. Can I pause and check something?
Of course. What's up?
Didn't we already spend a ton of time talking about literature reviews back in Chapter 2?
We did, yes.
When we were figuring out how to pick a research topic in the first place, why are we doing this again in Chapter 11? How is this different?
That is a vital distinction to make, and it confuses a lot of students. Back in Chapter 2, you were in exploration mode.
Exploration mode.
You were reading the literature to discover a gap in human knowledge. You were trying to figure out what you even wanted to study. You didn't have a hypothesis yet.
I was just searching for a good question.
Exactly. But here in Chapter 11, the experiment is already completely finished. You have your data. You are now using the literature in persuasion mode.
Persuasion mode. Okay, I like that.
You are carefully selecting and organizing previous studies to build a logical argument. By the time the reader hits your hypothesis at the bottom of the funnel, they should be nodding along thinking, well, obviously, this is the next logical experiment to run.
So Chapter 2 is about finding the question. And Chapter 11 is about convincing the reader why that question was absolutely necessary in the first place.
Precisely. You are retroactively justifying your work. And once you have justified why you did the study, you have to explain exactly how you did it.
Which brings us to the methods section.
Yes, the method section.
Let's return to your open source code analogy from earlier. If the method section is the code, it has to be absolutely flawless, right?
Right.
Because if one variable is left undefined, nobody else can replicate the study.
That is exactly the standard. The defining characteristic of a world-class method section is replication-level detail.
Replication-level detail.
Yes, a researcher sitting in Tokyo reading your paper should be able to set up a lab, recruit participants, and run your exact study without ever needing to email you for clarification.
That is a high bar.
It is, which is why the section is usually broken down into specific subsections. The most common ones are participants and design and procedure.
Let's start with the participant subsection, because this seems like it needs to be more than just a simple head count.
Oh, it is much more. It is the absolute foundation of your study's external validity.
Meaning, who can your results actually generalize to out in the real world?
Exactly. You must explicitly state how many people were involved, their gender breakdown, their mean age, and their specific demographic characteristics. But you also have to explain how they got into the room in the first place.
Like the recruitment method.
Yes. Did you randomly sample a whole city? Did you pay them $50 each? Did you force undergraduate psychology students to participate for course credit?
Let's pause on that last one, because that is a massive issue in psychology research.
It really is.
If your participant pool is exclusively 19-year-old college freshmen who are participating just to pass Psych 101, you have a highly specific subset of humanity.
Very specific.
You can't just take data from that group and confidently claim it applies to a 65-year-old retiree or a 40-year-old construction worker.
You absolutely cannot. And this is known in the field as the weird problem.
Weird, spelled W-E-I-R-D.
Yes. It stands for studying populations that are Western, educated, industrialized, rich, and democratic, and then pretending those results apply to the entire human race.
Which is just bad science.
It is. The participants section forces you to be transparent about who you actually studied, which keeps your broader claims in check.
Okay, so once the reader knows exactly who is in the study, they need to know what happened to them. Which brings us to the design and procedure subsection.
The meat of the recipe.
I feel like this is where students struggle the most, because they tend to write it like a casual diary entry.
Oh, I read so many diary entries.
They write something like, first, we welcomed the participants into the room and offered them water. Then we gave them a test on a computer, and they seemed a bit tired, but they finished it.
And that diary format is a nightmare for replication. There is zero scientific precision there. This section is where all the theoretical concepts from chapters 4 and 5, measurement and experimental design, suddenly become incredibly concrete.
So what do they actually need to write?
You must explicitly identify your independent variable, which is the thing you manipulated, and your dependent variable, which is the thing you measured.
And you can't just rely on conceptual definitions here, right?
What do you mean?
Like if my student project is investigating whether stress impacts memory, I can't just write, we manipulated stress and measured memory.
No, because those are invisible concepts. You can't put stress on a table and weigh it. You have to provide the operational definitions.
Yes. Let's role play this. Walk me through how you would operationally define those variables to make them visible and measurable for a reader.
Okay, let's think. For the independent variable, stress, I might write. Psychological stress was operationally defined by randomly assigning participants to either plunge their non-dominant hand into a bucket of ice water for 3 minutes, which is the high-stress condition, or to plunge their hand into room temperature water, which is the control condition.
That is beautiful open source code. You took the abstract concept of stress and translated it into a physical, measurable reality. Ice water versus warm water. Now do memory. For the dependent variable, memory, I would write. Memory was operationally defined as the total number of words correctly recalled from a 50-word list after a 10-minute delay.
Perfect. There's no ambiguity there. Anyone could replicate that. But you also have to document all your environmental controls in this section.
What kind of controls?
Well, did you use a within subjects design where every single person experienced both the ice water and the warm water? If so, did you counterbalance the order to prevent practice effects?
Right, because if they do the memory test twice, they might just get better at it the second time.
Exactly. And how did you control for demand characteristics? Those are those subtle, unintended cues that might tip the participant off to your hypothesis.
So I have to record every single decision to prove I control the environment. I'd write something like, participants were isolated in a sound-attenuated room. Instructions were delivered via pre-recorded audio to eliminate experimenter bias.
Yes. You are essentially creating a master blueprint.
Okay, so the blueprint is done.
And that blueprint leads directly into the climax of the paper, the results and discussion sections. This is where we finally get to open that digital folder on your desktop and actually look at the data.
The fun part.
But there is a very specific translation process that has to happen in the results section. You do not just paste a giant Excel spreadsheet into your Word document.
No, raw data is essentially unreadable. You have to guide the reader through the numbers. I've always thought of the results section as requiring the author to be bilingual.
Bilingual! I love that. Explain what you mean.
Well, you have to speak the language of statistics, obviously, but you also have to speak plain English so the reader doesn't get lost in the math.
That is a fantastic way to describe it. Let's break down the statistical language first.
Yeah.
You always start by reporting your descriptive statistics.
Which paints a picture of what happened.
Right. You report the means, the averages, and the standard deviations for your different groups.
So going back to our cell phone and driving example from earlier, you would report the average braking reaction time for the cell phone group and the average braking time for the control group.
Exactly. But descriptive statistics don't tell you if the difference between those two averages is actually meaningful or if it was just a random fluke. To answer that question, you have to move to inferential statistics.
This is where we run tests.
Yes.
Yeah.
You run a test, like a t-test, and you report the p-value.
Let's drill into the mechanism of that for a second because p-values confuse everyone.
They really do.
If I run my t-test and I report a p-value of 0.02, what am I actually telling the reader?
Okay, here's the translation. You are telling the reader that assuming the null hypothesis is true, meaning assuming cell phones actually have zero effect on driving whatsoever, there is only a 2% probability that you would see a difference in braking times this large just by random chance.
2% is very low.
It is very low, and because it is so low, it gives you the mathematical confidence to reject the null hypothesis and say, this effect is statistically significant.
But wait, statistically significant just means the effect is likely real, right? It doesn't actually tell you if the effect is large enough to matter in the real world.
That is exactly right, and it's a huge misconception. Significance does not equal importance, which is why you also must report an effect size, like Cohen's d.
Let's talk about Cohen's d.
This is a crucial concept. Imagine two bell curves overlapping. One curve is all the braking times of the control group. The other is all the braking times of the cell phone group. If Cohen's d is small, like maybe 0.2, those two bell curves are almost entirely overlapping.
So the difference is real, statistically, but it's tiny.
Exactly. It might just be a fraction of a millisecond. Technically significant, but practically meaningless. But if Cohen's d is large, like 0.8 or 1.0, those bell curves are pulled far apart.
Meaning the cell phone group is noticeably dangerously slower.
Yes. So the statistical language looks like a dense string of algebra on the page. T of 38 equals 2.45, P equals 0.02, D equals 0.8. But if you just drop that math equation into a paragraph, human eyes will completely glaze over.
This is where the bilingual translation comes in.
Exactly. Show us how it's done.
You have to state the finding in English first. So you write a sentence like, participants engaged in a cell phone conversation exhibited significantly slower braking reaction times compared to participants in the control group.
Plain and simple.
And then immediately following that English sentence, you put the statistical algebra in parentheses as your actual evidence.
Yes, you make the claim in human language, and you support it with the mathematical evidence. It is a perfect pairing. Now, once you have translated all your findings, you transition into the discussion section. And remember the funnel metaphor from the introduction.
Yes, starting broad and narrowing down to the specific hypothesis.
The discussion is an inverted funnel. You start at the narrowest possible point, and you slowly zoom back out to the broad, real world.
So the very first paragraph of the discussion is highly focused.
Extremely focused. You open with a clear, plain English summary of your primary finding. No p-values, no standard deviations. You simply answer your original research question. Did the data support the hypothesis or not?
So I just write, the results supported the hypothesis. Cell phone use delays braking.
That's it. Start simple. And then as the funnel begins to widen, you interpret what that actually means. You discuss the theoretical implications.
Like, does this finding challenge existing models of human attention?
Exactly. And you also discuss practical implications. What does a large Cohen's d for delayed braking mean for public policy? Should hands-free devices be completely banned?
You are connecting your isolated, weird laboratory experiment back to the messy reality of society.
Yes, but to do that ethically, you must engage in rigorous critical thinking. You have to admit your study's flaws.
The limitation section.
You must include a section on limitations.
I know students really struggle with this part. There is this overwhelming temptation to write a massive laundry list of every tiny thing that went wrong in the lab.
Oh, I've seen it all.
The air conditioning was loud, or one participant seemed grumpy today, or my computer froze for a minute during trial 4.
Please, whatever you do not write an apology letter for your study. Every single experiment in the history of science has minor, annoying flaws.
So what are we actually supposed to report?
When writing the limitations section, you are only looking for major threats to validity, fundamental issues that could genuinely change the interpretation of the results.
So we're primarily looking for threats to internal validity and external validity.
Yes. Let's look at internal validity first. You are asking, did my independent variable actually cause the change in the dependent variable, or was there a confounding variable lurking in the background?
Can we apply that to the cell phone study?
Sure. Imagine the control group was tested on a Tuesday morning, but your cell phone group was tested on a Friday afternoon when participants were completely exhausted from the week.
Oh, that is a massive confound.
It is. It severely threatens internal validity. You have to openly state in your paper, a major limitation of this study is the lack of temporal control, meaning participant fatigue cannot be ruled out as a contributing factor to slower braking times.
You are preempting the critics by critiquing yourself first.
Exactly. It shows you are a thoughtful researcher.
Hmm.
And then for external validity, you have to admit if your setup was just too artificial.
Right. Like if my driving simulator was essentially just a cheap desktop monitor with a plastic steering wheel plugged into a USB port.
Which it often is in an undergrad lab. You have to admit that the results might not perfectly map onto the incredibly complex visual and physical environment of driving a real heavy vehicle at 70 miles per hour on a highway.
You expose the major flaws, but then you do something brilliant, right? You suggest a future study that could actually fix those flaws.
Yes. You write, future research should utilize immersive, full cab driving simulators to increase ecological validity.
You are literally handing the next researcher their hypothesis for their next paper.
You are passing the baton. It feeds right back into the cyclical model of science. You keep the cycle spinning.
Okay, so that covers the whole paper.
It does. Now let's assume you have written this beautiful, meticulous APA-style paper. It has the funnel introduction, the open source method recipe, the bilingual results, and the self-aware discussion.
It is ready to go.
You submit it to an academic journal, but journals are slow.
Very slow.
The peer review process can take months or, frankly, even years. If the scientific community only ever communicated through published journals, the entire field would advance at an absolute glacial pace.
Which brings us to alternative ways to present research, specifically professional conferences.
Yes. Let's dive into the world beyond the paper. Professional conferences range from small regional university gatherings to massive international events where thousands of psychologists literally take over a city's convention center.
Sounds overwhelming.
It can be. And the primary way you share data there, especially as a student or an early career researcher, is through a poster session.
I've walked through a few poster sessions at my university. It is a very unique environment.
Describe the vibe for someone who hasn't been.
It feels a bit like a chaotic science fair for adults. You walk into this massive ballroom filled with hundreds of bulletin boards, and next to each board stands a researcher guarding a giant 4-foot by 3-foot printed poster of their study.
The energy at a poster session is incredible. It is loud, it is dynamic, and it forces you to develop an entirely different communication skill.
Because you can't just take your 20-page APA manuscript, print it out in size 12 font, and staple it to the board.
Definitely not. No one walking down the aisle is going to stand there for 20 minutes reading dense paragraphs of text.
You have to build a visual abstract.
A visual abstract. That is a great term for it. Creating a huge 4 by 3 foot poster forces you to distill your complex methodology and your dense statistics into a highly visual, bite-sized narrative.
So lots of graphics.
Yes. You have to rely on bullet points, massive, clearly labeled graphs, and bold headers. The goal is for a passing researcher to be able to grasp your research question, your basic method, and your core finding in about 30 seconds.
And if the visual hooks them, they stop, and that triggers a one-on-one conversation.
Which is the whole point.
That is the real magic of a poster session. You aren't just broadcasting data into the void. You are debating it live with other human beings.
Exactly. A senior researcher might look at your graph and say, have you considered running a different statistical analysis here? Or, we are doing similar work at my university, let's collaborate.
But let's ground this for the undergraduate listener who is just trying to finish their class project right now. A student might be thinking, I'm never going to present at a psychology conference. Why do I need to care about this visual abstract stuff?
It's a very fair question.
I would argue that learning how to construct a scientific poster is actually one of the most broadly applicable skills in this entire textbook.
Tell me why you think that.
Think about the mechanics of what you are doing. You are taking a massive, complex data set, identifying the core narrative, and designing a visual presentation to quickly persuade an audience of your findings.
Which is a universal master skill.
Exactly. If you go into business, you will have to present market research to executives who only have 5 minutes to spare.
Very true.
If you go into medicine or public health, you will have to explain complex epidemiological data to politicians or patients using clear visuals.
Or if you are in software engineering, you have to justify your architecture choices to a project manager.
Right. Whatever career path you take, you are going to be an advocate for data. If you collect incredible information, but you cannot explain it to an audience visually and verbally, the data is essentially useless.
Chapter 11 is fundamentally a masterclass in professional communication. It is about making truth legible to other people.
It really is.
Well, we have covered an immense amount of conceptual ground today.
We covered the whole process.
We did. Let's transition into our review section to really lock these concepts in. We'll start by synthesizing the journey into 5 major takeaways.
Let me take a stab at summarizing these, just to make sure I've got it.
Go for it.
Okay, takeaway 1. Science is a social, cumulative process. A study isn't truly finished until it is shared with the community to be critiqued and built upon.
Spot on.
Takeaway 2. APA style is not an arbitrary set of rules to torture students. It is a universal coding language for psychology. It operates on 3 levels: organization for predictable structure, high-level style for objective tone, which includes person-first language, and low-level style for granular citation mechanics.
Excellent.
Takeaway 3. The introduction functions as a funnel. It must hook the reader broadly, use a literature review to build a persuasive argument, and narrow down to a highly specific hypothesis at the bottom.
Perfect funnel analogy.
Takeaway 4. The method section is the open source code of your study. It requires replication-level detail, meaning you must explicitly define your variables, your measurement tools, and the demographics of your participants.
And takeaway 5.
Takeaway 5. The discussion section is an inverted funnel. You translate your statistical findings into plain English, widen the scope to discuss theoretical and practical implications, and rigorously evaluate your own major limitations regarding internal and external validity.
That is an impeccable summary. You nailed it. Let's test that knowledge with our review quiz. We are going to do this rapid-fire style. If you are listening, try to beat our expert to the answer. Are you ready for the lightning round?
I am ready. Fire away.
All right. Question 1. Which level of APA style dictates that a researcher must use person-first language, avoiding labels that reduce a participant to a single diagnosis?
That is a rule of high-level style. It governs the overarching tone of objectivity, ensuring we treat participants accurately rather than just as productive variables.
Correct. Question 2. In which specific subsection of the empirical report do you explicitly reveal your independent and dependent variables?
Well, if the method section is the code, the design and procedure subsection is where you define the specific mechanics. That's where the variables and operational definitions live.
Right on the money. Question 3. Why is it considered unscientific to write, "The data prove my hypothesis"?
Because of inferential statistics. We are sampling a small group to infer truths about a massive population. Probability dictates we might be making a type I or type 2 error, so we must hedge our language by saying, the data suggest. There is no absolute proof, only evidence.
Excellent connection to probability. Question 4. Thinking about the funnel metaphor of the introduction, what are the 3 structural components?
You open wide to establish the real-world context, you narrow through the literature review to build the justification, and you close at the very tip with your specific hypothesis.
Spot on. Final question. What is the standard physical size of a visual abstract presented at a professional conference poster session?
They're usually massive, measuring roughly 4 feet wide by 3 feet high, forcing the researcher to prioritize visual communication over dense text.
You survived the lightning round. Great job.
Thank you, thank you.
Now, to make this actually actionable for the listener who is working on a project right now, what are 3 reflection questions they can ask themselves about their own research?
If you are currently designing a study, I think you should ask yourself these 3 things. First, really scrutinize your method section. Have you provided a tight, specific operational definition for every single variable? Could I read your paper tomorrow and perfectly replicate your physical setup without asking you a single question?
That's a great test.
Second, project yourself to the end of the study. If your data comes back exactly as you hypothesized, what is one major, undeniable threat to your internal or external validity that you will honestly have to confess in your discussion section? What is the biggest flaw in your design?
Love that. Preempting the critics.
And third, audit your rough draft. Are you using any language that objectifies your participants or reduces them to labels? How can you rephrase those sentences to prioritize person-first language?
Those questions will dramatically tighten up any draft. I highly recommend pausing and actually answering those. Now, as we wrap up this deep dive, I want to leave you with one final, slightly provocative thought to turn over in your mind.
Ooh, provocative.
We spent this entire hour talking about the mechanics of sharing successful research. We talked about how to write up the studies that worked, where the p-value was significant and the hypothesis was beautifully supported. But let's tie this back to the replication crisis we discussed in earlier chapters. What happens to the studies that fail?
Yes, the infamous file drawer problem.
Exactly. Right now, as we speak, across thousands of university servers, there are flawlessly designed, rigorously executed studies where the statistics came back non-significant.
Meaning the null hypothesis was not rejected.
Right. And because academic journals have historically been massively biased toward publishing exciting, novel, statistically significant findings, those failed studies are never written up. They're abandoned in a digital file drawer.
But wait, if a study is genuinely well-designed, finding out that 2 variables are not connected is still a massive scientific discovery.
Absolutely.
Knowing that a specific experimental drug does not reduce anxiety is critical data.
It is arguably just as vital as knowing what does work. If the entire foundational purpose of Chapter 11 is to add to the cumulative scientific literature, shouldn't researchers be ethically obligated to write up and present their non-significant findings?
They absolutely should.
Think about how much time and funding is wasted globally because a researcher runs an experiment, unaware that 3 other labs already ran it and found nothing, but just never published it.
Because they were embarrassed it didn't work.
Exactly. Imagine how much faster the science of psychology would advance if we published our dead ends and our raw, uncooperative data just as loudly and rigorously as our successes.
It requires a massive culture shift in academia. We have to stop viewing non-significant data as a personal failure and start viewing it as a crucial piece of the map that shows the rest of the scientific community where not to dig.
A map showing where not to dig. I absolutely love that. So the next time you are staring at a spreadsheet of data that didn't do what you wanted it to do, don't just sigh and close the laptop.
Don't hide the data.
Use the tools of APA style, write it up clearly, and get it out into the conversation. Keep asking rigorous questions, keep refining your methods, and please, whatever you do, don't leave your data trapped in the folder.